Okay,
Minus 1 is 71.
we are now recording. There we go. Good morning, class.
Good morning, Dr. Moore.
How's everybody this morning?
As good as you can be after being pulled over by the cops.
Oof.
But it was my fault, and I was driving way too fast, so. But it was a
Well,
nice cop, and instead of being $600 poor, I'm $100 poor, so
well,
we're good.
that's certainly not the least desirable outcome. Mouse, there it is. So, you know, we've been doing this class for most of the semester at this point. It still feels pretty early in the morning.
Well,
I
it's
haven't
7
gotten
a.m.
used to it.
now.
What, sorry?
It's 7 a.m.
Oh, that's true, yeah, we
Since
just
the time
have,
change, I've been sleeping in an hour every day.
bloody oh, yeah.
I love it.
Yeah, you like the spring forward?
Yeah, well, I just wish they'd pick one. Just pick one and stick with it, and I'm fine with either way you do it.
Yeah.
But just, it's the changing that bothers me.
I agree. It's, I've never been quite sure or clear on the purpose, you know?
Supposedly, it was during World War II to save electrical, I don't know, it has to do with the war and having more time during the light hours, so you use less electricity, I don't know. I looked it up, the justification up once, and it seemed flimsy at best.
See, this is like yet another theory I've never heard of to explain daylight savings time, where I've already heard like 3
Oh yeah?
alternate theories to explain daylight savings time. I've heard the explanation that people buy more when it's light out, so it's like a conspiracy by retailers to try to make it so there's more daylight,
That's too QAnon.
you know, during the daylight hours, so you shop more. I've heard that it somehow helps farmers somehow, you know, I think that honestly at this point, I think we just do it because the Americans do, and it'd be too much hassle
Yes.
setting your watch when you go
No,
over the
because
border.
our biggest trading partner is New York State, and we can't be an hour off from New York State. So
Yeah,
whatever New York State does, we have to do.
that's
Our
why
power-
we do it,
Our
yeah,
power grid is so intimately connected with the United States
yeah.
via Niagara Falls that we can't screw around.
So, you know, that means that as Canadians, we can conveniently once again offload the blame for this to the Americans. Who the heck knows why Americans still persist in doing this? Honestly, at this point, I think it's just the lizard people messing with us. I think that's probably the most plausible explanation. Is the world is run by lizard people and they just like messing with us. That's it. That's a joke. I don't actually believe the world is run by lizard people. Although, if you look at
And those who exist do believe that though, so.
yeah, if you look at the Facebook guy and the right lighting, you can see where they're coming from. But you know,
Well, what was it? Something like 40% of the milk, chocolate milk, comes from brown cows.
12% of dudes think they can beat a grizzly bear in a fist fight.
That's all right.
Can you imagine that?
if you get attacked by a shark, all you do is just punch the shark, right?
Right on the nose.
Yeah, just there you go, shark immunity.
Pretty sure that's the logic for most animal attacks. Just punch it.
My goodness.
You know, the line comes out.
Piss it off
punch
more.
If you punch it hard enough, it'll go away.
Something will work.
Unless it's a goose.
Yeah, those things are annoyingly persistent.
Wow. They literally just replaced this thing, and look at this already. Like the friggin' rest for your wrists on this. already substandard keyboard
Glued
tray.
in?
Yeah, like you win IT or facilities or whatever it is.
Up the
I'm
state.
sorry I complained that the keyboard tray was broken. It now gives the impression of functionality instead of actually not having the functionality. Goodness me. Anyway, I'm doing a lot of complaining this morning. I apologize. Should be positive and cheerful in everything we do. So, let's take a look at what we got this week. So last week we did inheritance. Might do a couple of examples, programming examples, before we move on to week 9, polymorphism. So, just to put this on your radar, your collective radar screen, this week we are covering polymorphism, which is more stuff to do with inheritance and is probably conceptually the hardest material in the class. And then next week there is test 2. Test number 2, you'll find the format is quite shockingly similar to test 1. They are cut from the same cloth, you might say, except of course the questions will be different. That's the main difference between test 1 and test 2. Once again, you have a practice test available to you. Again, we will have our test during our Friday class, and we will use the Wednesday class, this class, in order to go through the test practice material, do our little in-class test quiz thing, and that's how that's going to go. Any questions? Yes.
Polymorphism will be in there.
Sorry, could you repeat that?
Polymorphism will be in the exam.
Test 2.
One more what? Sorry?
Polymorphism.
Polymorphism. I suspect not, but I will confirm that with the test itself to make sure that there's no polymorphism on that. But in the past, the polymorphism has been saved for the exam, or covered in a very kind of general theory kind of a way, and not necessarily with hard coding questions. I don't mean hard to mean difficulty in this sense, just in the sense of tactile. Anyway. Practical questions might be a better way to put it. Anyway, so, I see I'm missing the assignment for this week. Alright, the assignments this week, I will hunt it down, I will post it, and it will be introduced next class. For now, let's take a look at our programming exercises for inheritance, as we didn't get a whole lot of time to practice it. So, quickly and quietly, please. So, thank you. So, you two at the back, if you wouldn't mind. Shh. It's a lesson. So, if we recall our geometric object example from last class, these methods, we collected up the commonalities between our circle and rectangle classes, and we collected them into geometric objects. Now, in our example code, there is still a little bit of work to be done in collecting up the commonalities between these files. So our first exercise is to collect up some of all of the duplicate code that you can find in the draw methods specifically of the circle and the rectangle class. Add a method to geometric object which contains those common pieces of code, and then appropriately call that method from both of the subclasses. Does that make sense? So, just to remind ourselves, the code that we're looking at here is in the example code for week 8. You're late! Quickly and quietly, please. So, as you can see, we have lots of Java files here. Please take a moment to get IntelliJ up and running. And the ones that we are particularly interested in right here are circle and rectangle and geometric object. Pull those into the source folder. In theory, this should work. There we go.
The package?
Yeah, it's the packages. Just delete the package line. So in Java, what the package line means, there's an expectation in Java that the package or the sub-package or all of the package structure corresponds to folders within the source folder of your project directory. So if it says package week 8 code, it needs to occur inside of a directory called week 8 code. It's, generally just in the way most of the time. We are not really using packages, as packages here, so it's kind of just, I end up just deleting the package statements. Many of you submit Java files with package statements, and I have a little script that goes and scrubs them all out before I try to run anything. And that makes everything work much better. So, let's remind ourselves, here's the geometric object class. We have radius, set radius, get area, draw, and public to string. Oh no, I'm sorry, this is circle, extending geometric object. I was like, why is geometric object having a radius? Sorry, this is circle, right? Circles obviously have a radius. We then also have geometric object. X and Y position are both aspects of that. We have stroke color, fill color, line width, all of these nice properties. You'll notice that the geometric object class does not have a draw method. So, what we want to do is we want to add a draw method which the two classes, circle and rectangle, will override. Alright? Taking a look at rectangle, this is the draw method. we've got a number of different statements here. In the circle method, you'll notice that there are some commonalities between these. So, I'll give you, let's say, 5 minutes to collect up these statements and put them in a method in the geometric object class such that you can minimize the amount of code redundancy between these two classes which are doing the inheriting. Okay? So, I'll give you 5 minutes.
We have to drag them into the source folder. That adds them to the source folder. Here, if you get the little cup icon, it means you've just loaded a Java file somewhere else. So it's just basically here functioning as a regular text editor. It's not like integrated into it. It's not integrated into its compilation system. So just drag it into the source folder.
I don't think it works either. So that's why I need a main method so I can start running and figure out why it's not working. It's not gonna work. Because I'm not calling the draw. It's gonna override that. And it's gonna ignore the.
The only thing I would say is, if this is a model control, it should only have output.
Should go like super.
That's what I was doing, I was switching the values, I just wanted to hit your on the thing, that should be included, change here,
Okay, so.
Would you prefer, just do a grand on that, because I haven't set something like this, just to avoid a weird instances where I create something that's already dead.
Yeah, there are
There's no
also,
main method.
like, you want to avoid zero division errors.
That's not what we're making that. That's not how it is. Exactly what I'm
yeah.
doing that. I need to see the error.
Yeah, so, yeah, no,
That's what I'm struggling with. I need to talk to him about it. I can see I've done everything except for associating with path tracking. Right now, the way I have it working, everywhere we have to move it is an alpha as path as well. I
You're supposed to write a draw method,
can't figure out how to make it
Right.
work if I'm
which
associated with
incorporates the lines of code which are common to the draw methods of the circle and rectangle classes. So that when overloaded and called correctly, you minimize code redundancy.
So it inherits from a path method. It also has path method. And this is a really big path. It's got a couple constructors. You can give it string name, path name, or you can give it all of the values. So once you give it the first constructor, it gets random values. So that every slide sets the path name to the name of the variable. And then creates the path object that's attached.
the amount of progress that we've made so far really makes me feel super.
No, see. You can't because you unlimited report, how big, how, you know, how big to make that array? You don't, that's why you need to use an array best, it's not about that. We haven't got that yet, so that's not what we have to do, they won't expect us to do things that we haven't. So, the other way, and now I can't create a normal way, because every time, a little more work, I feel kind of bad. So, two ways I can do it. You can do act as a standard method. Right now, I'm in the alpha control all the actions of that, add the education, and the acts and the
Okay. So, this is how it works. In order to define the draw method in the geometric object class, it must have the same type signature as the methods which you are setting up to overload it. So, you actually get to just copy and paste this line of code, public void draw graphics context, into your geometric object class. Does anybody care to tell me which lines of code particularly are common to the circle and rectangle classes?
The first three?
That is correct, the first 3 lines. So we can cut those, add them to our draw method, and also remove them
from the circle and rectangle.
from circle and rectangle, yes. So, the issue then becomes these overloaded definitions of draw do not automatically invoke their super method, or the thing which is the thing which they are overloading. So, in order to do that, we use a very similar process that we use on constructors. Question?
Are they overloading or overwriting?
Oh, I'm sorry, yeah, they're overriding, not overloading. Apologies. Yeah, they're overriding, pardon me. Overriding. Apologies. So, essentially,
It's gonna be on the test, so we gotta get it right in our head.
yeah. Yeah, it's, again, just a little bit early in the morning. Super.draw. Super.draw, and then we give it the argument it's expecting, which is a reference to the graphic context being passed in as an argument. There we go. Super.draw. This invokes the overridden method in the geometric object class. This is the key ingredient. And of course, the circle will require the same thing. There we go. Question?
I just found a neat thing, because it sets the stroke and fill, and you draw the circle first. I had it done in the circle class, but not in the rectangle class, the super. And the rectangle class still was drawn with the appropriate colors, because it was already set beforehand.
Yes.
As long as they're the same color.
So yes, this is a true and correct observation. So your classmate has observed that if super.draw is run for the first object which is drawn, those modifications, those colors which are set for all subsequent elements that are drawn. Of course, this is how we understand JavaFX to work so far. When we set the line color or the fill color, that parameter stays set until it's reset, so it makes sense. But despite that, it's still absolutely a good idea to run super.draw in all methods, as in this particular instance, our circle and our rectangle are the same color, but this is not necessarily so, right? And one of the things that you want to avoid in object-oriented programming is this sort of implicit rule that one method should be executed before another, right? That actually works, that cuts against your encapsulation and your modularity, right? And it makes your program much more difficult to understand for anybody who's trying to use it, including yourself, right? Think of it this way, right? Let's imagine that you, like, I'm not saying that you would do this, obviously, you know, but let's say somebody noticed that and they were like, oh, I don't even have to add the draw method over here. I'm getting what I want anyways. I'm going to stop there, which is a temptation. I know perhaps not for all of us, but for some, just stopping as soon as it's working is a temptation. So, especially if you don't document that that's expected behavior, imagine you leave for 3 weeks or 3 months, you come back to the same code, you have forgotten everything there is to know about this code, right? Another thing that you have forgotten is all of these stupid little implicit rules about how the code is to be executed, right? If you have like little rules about your code, like this method needs to be called before that method in order for it to work, basically you're setting yourself up for failure. And that's not maintainable code, right? It's also not a very nice thing to do to someone who's working on a project with you. So,
That makes you a bad programmer.
yeah, it makes you a bad programmer. So, there are some languages where these types of implicit little rules are, like back in the day, we didn't care so much about trying to stomp this type of behavior out. This back in the GoTo days and back in the days of Fortran and Lisp and COBOL. Basically, if the computer, it was sort of considered back then that if you got the computer to do what you wanted with as few like the smallest number of lines of code possible, while relying on all of these implicit little things, like that meant that your code was good code because the memory was so constrained that like you wanted your program to be as small as possible. This feeling somewhat persists to this day. People think themselves clever when they write code that can't be understood by anybody else. But communication. It's the most important thing. You have a question?
Just to be clear, his little trick only works because you call circle first. And
Precisely.
If you called rectangle first, everything would crash.
Yeah.
Exactly.
Well,
Yeah.
it wouldn't crash, you just get black
Yeah.
rectangle and then
It would work, but you wouldn't know why you weren't getting anything, and you'd be like, oh.
You'd be getting the wrong color and you wouldn't know why.
Yeah.
And while it seems wasteful to reinitialize the colors and reset the colors every time you call the draw method, what you gain by that is modularity, and the modularity is much more valuable than
Sure.
the 3 method calls that you would save.
Because then you need to call circle to change the color of rectangle.
Yeah, exactly,
And
and
maybe
how
you
much
don't wanna
sense does
draw a
that make,
circle.
right? So, good. Wonderful. So, let's create a square class using inheritance effectively. Be sure to include a getArea, getPerimeter, and draw method. So, I hope everybody gets the answer to this question, but what is the difference between a rectangle and a square?
Square has the same length on all sides.
Precisely so, whereas a rectangle has 2 groups of sides of 2 different lengths that are opposite each other in the figure. So, create a class for squares, use as much of the rectangle class as you possibly can. The more you copy and paste, the more you make sad puppies cry. So, we'll take maybe 5 or 10 minutes for this. Oh, man. So, rule of design for these things, never modify the parent class to do something for the child.
But, I mean, like, can I, in the reference of the square class, can I remove its inheritance versus can I have no inheritance? Or do I just have to say they're the same function?
I don't know if you can.
Cause I'm just set them to do the same thing. I can say set height just does set width.
Yes. Yep, I think, that's probably.
Is that what you're gonna do?
Yeah, I'm gonna make use of it rather than redefine things. Basically, we wanna put it this way. We're gonna provide an interface to a rectangle that makes it into a square.
I'll see.
As little as possible. Okie dokie. Let's see where we are. So, we want to make a square class, so let's do that. Square, there we go. Extends what?
Rectangle.
Yes, how many people put geometric object? Nobody? How many people put rectangle? Okay, yes. So we have to pick the correct level of the hierarchy at which to inherit. A square can be considered a particular variety of rectangle. Rectangle is a more general description that includes all squares, right? Geometric object is more general still, but if you think in particular about the methods that would be used to draw a square, these are identical with the the draw method between the rectangle and the square should be precisely identical. So, let's take a look. Let's side by side this. There we go. So, in our geometric object class, we have,
That's rectangle.
pardon me, yes. In rectangle, we have width and height as separate variables. Now, in theory, for a square, it should only be required to have one variable for side length. However, if we do it that way, we lose a bunch of other lovely methods included here, such as get perimeter, which,
This works.
it'll still work. What we need to do is to constrain width and height so that they're always the same. So, we can do that using the constructor. And I'm noticing that this thing does not have a constructor, so perhaps it should have one.
It has a comment in the beginning that
Yeah.
constructors removed because they require a separate discussion.
Oh,
Yep.
well, I'm gonna put it in. Alright. So. There we go. So, now that we have a constructor in the rectangle class, we require one in the square class, as the default constructor no longer applies. So, public square. A square has only one side length, right? Only one item of note, so we should have one input to the constructor. Double side length. Now, calling super, passing side length and side length, passes the passed side length value to both the width and the height. Therefore, the width and the height are constrained to be the same. Now, it is perhaps the case that we want the ability to set the side length and retrieve it. This is a bit different from getting height and width, right? Essentially, we need to set both width and height at the same time. So, public void set side length, receiving double SL for side length. Super dot set width side length. Super dot set height side length. Now, at this point in time, we don't actually need super in order to access these methods.
Can you zoom that a bit, please?
Oh, yeah, absolutely, sorry. Zoom, 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 zoom. Is that good?
Yeah.
Awesome. We don't actually require super in order to access set height and set width. These are public methods which are inherited, and the definitions are available inside of the Square class. So, may I ask, why would you imagine that I would use super here? What am I intending to do?
Readability, for better readability, so that better understanding.
Yes?
You intend to override set width.
Yes. I'm intending to override both set width and set height. Therefore, I am, at this point, explicitly referencing the super versions. And because I'm referencing the super versions, I also get this lovely error check, and I don't have to re-implement it. So, on a square, setting the width and setting the height should all do the same thing, right? So, we can override. Again, the override tag is unnecessary. It's just for the compiler to know that we are intending to override something. But, it's also kind of like, okay, I'm writing an override method, gonna use the override keyword. This reminds me that this overrides something. It's like self-documentation as well. Yes?
For documentation on the assignment, do you want to add override?
Preferred but not required. So, public void set width takes double width, sure. And then we also have public set height takes double height. Now, the definition of set width and set height is that they should set both the width and the height from either of these, right? Both width and height should always be modified at the same time by the same thing. So, we already have a method that does that. What is it?
Set sideline?
Set side length. Set side length to the passed parameter w. Set side length to the passed parameter h. There we go. Get width and get height do not require modification, but it might also be useful to have a get side length, since that keeps it consistent, right? Basically, what the square class is doing is it's setting up an interface for an instance variable side length which doesn't actually exist, right? We don't have a side length instance variable in this class, yet we provide both getters and setters for a side length variable. At least it gives the appearance of such. So, to complete that, public double get side length. There we go. And what should we get for our side length? Does it matter?
It should be the same, right?
It should be, yes. So if we have done our jobs correctly, there's no possible way that width and height are different, so it doesn't matter which one you pick. So let's just return get width. Remember, get width is public, so it is available inside this scope. Does this make sense? So the reason that this works, right? Note that these variables are private and not protected. With our rectangle class, all of these set methods allow us to modify the width and the height individually. Here in the square class, all of this is buried, right? Remember that you can't actually get through to these definitions through here just by supering multiple times. You must go through this interface to access the rectangle material. So if it's public and you leave it alone, that's fine, it's just by default exposed. But if you override it, the overridden version must be used, like basically there's no way to jump around it, right? You can't just super your way up to the rectangle definition. So, because these variables are private, and because we have overridden every method, every possible way of setting them, there's no way to set them except through this, the constructor up there, or these three methods, right? So, basically, the whole point of doing this is so that we can make some assumptions about what the values contained in those variables are, right? The longer you go on in your programming journey, the more you will realize that you spend half of your time setting up these kinds of meta properties in variables, right? And hopefully you document them as well. But the idea that you now have the ability to create essentially a rectangle class where the side length, the width and the height cannot be different because you cannot set them differently, right? This means that you can assume that these two variables always have the same value, which allows you to make certain assumptions, simplifications, and in some cases, stuff like this allows you to apply algorithms that you wouldn't otherwise be able to apply. One of these meta properties, which is very highly important and you will study extensively in your 4th semester algorithms course, is the property of sortedness. Sortedness is an extremely important property in computing. It allows you to apply super duper efficient algorithms for searching things and finding things and insert operations and all of that type of thing. It's very, very useful to have sorted data. I read in a textbook that was written some years ago, and this is probably still true. I read in this textbook that 30% of all computation is sorting. So 30% of everything a computer does is sorting data. So it's important, therefore, that sorting algorithms be efficient. But anyway, did you have a question?
Yes, so, I know you're gonna say this is bad practice, but would it not make sense as well to just put a boolean into rectangle and says is square, and then modify the functions as though it is a square? Check to see if it's a square and then do things as though it was a square there.
So, obviously that would work, right? If you wanted to implement a square as a rectangle, you could just, add a few extra things to the rectangle class so that it also supports square functionality, right? There's no reason we couldn't take most of the contents here, we haven't barely done anything, right? And just pop it over there, everything would be fine.
Can you just make a square by giving rectangles height and width the same?
Yes,
So
absolutely.
Why would you corrupt your method instead of telling people if you want a square, just make the height and width the same?
Well,
Because we're trying to learn about inheritance.
we are trying, it's also useful to have a data type.
Well, that's why you should make a square class and not corrupt your rectangle class to make a square.
Well, I wouldn't necessarily call it corruption if the code works, but
So my thing
yes,
is that in the square class, you have set side length, set width, and set height. But they
Yes.
all do the same thing.
yes.
And that's loaded.
I mean,
And it
Yes.
makes it more unclear.
well, yes, but that's Java for you. Yes.
Is it fair to say the reason to do it like that is to avoid an if statement? So it's just basically avoid if width and height are the same?
Yeah, it does. This is a positive a positive effect here is if we were dealing with the case of the square and the case of the rectangle, the logic would become more complex, and this is it doesn't get much more simple in terms of logic than this, right? So if you want to keep your methods small, this is the way to do it. But the other thing is, what this allows you to do is it allows you to encode certain, it allows you to be more specific about things at the level of data type, right? One of the things that you will note about, especially once we get to the next unit, which is polymorphism, one of the things that you will see is that we can write things for more and less generality, right? Having the more specific data type available allows us to say, okay, the input I'm expecting to this method is a square specifically, and not a rectangle, or just a general rectangle, and I can enforce that at the level of the type checker itself, right? Rather than having to enforce that at runtime, which is preferable, because the type checker is your friend, do not anger the type checker, but the type checker is your friend, right? And because of the rules of polymorphism, you can actually provide, and like we'll get to this when we talk about this week's material, you can provide a subclass object where it's requesting a superclass,
Yeah.
right? So if you wrote two methods, one accepting a square and the other accepting a rectangle, the one that accepts the square must accept a square or any subclass, right? The one accepting a rectangle must accept a rectangle or any subclass, which includes a square,
Yeah.
right? So you don't lose any functionality, right? A square can still be put into any slot given by a rectangle, but it does open up the possibility of operations expecting only and just squares, enforced at the level of the type checker, which is, it's nice not to have to reinvent the type checker, right? And that's essentially what you're doing when you add a Boolean variable to rectangle, allowing you to consider it a square in some cases and not a square in other cases, is like you're doing work manually that you could be getting the type checker to do automatically.
Yeah.
Does that make sense?
Yeah, because it tells you it'll go, I can't accept that, but in mine, you'll run it and then you'll get an error going, it has to be a square.
Yes. So it's like generally a good rule of design to sort of force errors up earlier in the process as much as possible, right? There are some languages, one of my favorite languages is called Haskell. Haskell is a functional programming language. It is a bugger to get anything to actually compile in it, but once you get something to compile, you generally don't have, like, the amount of runtime errors that you have to fix is generally quite low in comparison to most languages. And the advantage of having runtime error, the advantage of having, compiler errors and type checker errors versus having runtime errors is runtime errors, you don't always get an error message, right? You have to find runtime errors using testing and other, like maybe static analysis or other types of things, right? And because you don't have an error message, it makes it much more difficult to fix and find the errors. So if you can force that stuff higher up the chain by using the type system effectively, then your code becomes, nicer, better, more maintainable, and more likely to run without runtime errors. So, yeah, that's the general reason. But yeah, no, I totally agree. You also could, in theory, hack out any Java program with inside of one big main method, right?
That's how I like it.
Yeah. So yeah, won't help you on the test. Okay. So So I would like to do one more example with from this page, and then we'll get on to our material for this week. This is a rather important example, I think. Child, parent, and grandparent classes. Fix them so no matter which version of foo gets called, it will add up the parameters and then pass the sum to the one parameter version in the grandparent class. How many different ways can you think to make this happen? Let's not worry about that so much as just getting it working. So, we've got, what was it? Person, child.
I think it's override child there.
Yes. Override child, override grandparent, and override parent. There we go. So in child, we have foo taking 1 and we have foo taking 3. You'll notice that all of these foo methods currently just output the parameters that have been passed into them. Oh, and get rid of the package statement as well. So basically, the point of all of this, this is an exercise in overloading and overriding. The point of all of this is that the only method which does outputting will be, like outputting using system.out.println, will be this highlighted definition inside of override grandparent. The point of this exercise is anywhere you have multiple inputs, those inputs should be summed arithmetically and then passed to an appropriate method so that this is the one that outputs everything. Okay? So you're trying to set up like a chain of overrides and overloads. You will need super for this. I'll give you 5 minutes. So get to. It's only important that a lot of the packs, right? General like that information has no, it doesn't pertain to anything for stuff.
Sorry, so in that case, you want the check to see if they're the same package, either which and where it was.
It should be, classes.
So if anything in that pack of packs, so essentially, if I was to make, so in the class state of the whole pack, and anything were to attack any, so whatever the attack is declared from the whole pack, it would check, so you'd have to pick an individual, and then that individual would check if the attack target is in the pack.
Yes.
And that's done through opening, that's through that whole pack, through the pack that assigns roles and witches.
Yeah, that's how it would make more sense to me.
Like with my initial method, just a matter of werewolf or witch. Just gonna check to see what the opponent was, the human.
But it seems, yeah, packs should be a class, not just like a value thing, not just like a instance variable inside.
Oh yeah, I know, just another, for the creation of a class, so we're making a class, and we're writing that, would you want to say we give it, give it a number, then we take it, and it'll take that many goals.
I'd have to read the description again to, I gotta.
Oh yeah, no, sorry, you got it. Sorry.
So all of these definitions should reroute to the definition in the grandparent, override grandparent class. Right? So ultimately, there should be like, I'm gonna show you before. But, like for example, foo taking 2 arguments should not be outputting.
it should sum those two and then call foo with one argument in the same class. That way, that's the empty one that's output at this level. Does that make sense?
Are we assuming 3 is the max? Are we assuming 3 is the max?
3's the max for what?
Inputs.
I mean, I think that's the maximum number that anything adds. There you go. Yeah, you only have to do the ones that exist.
Okay.
Okay. So, I'm going to start by doing a little bit of abbreviated UML. So we've got grandparent, right? Grandparent has foo taking 1 int and foo taking 2 ints, right? Not worrying about the content at the moment, but this definition here is the base definition that we want all other definitions to redirect to. In addition to the grandparent class, we have the parent class. The parent class containing but one definition of foo. Which takes 2 arguments. Yes?
Is that the correct way for the arrow for inheritance?
No. Terrible, 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 terrible. Parent extends grandparent. Thank you. And then we have the child class, which extends parent. The child class containing a definition of foo taking 1 and a definition of foo taking 3. So, in the final analysis, how many overloaded definitions of foo are there?
2?
I think 2.
So, if we instantiate a child object, how many overloaded definitions of foo can you use from that child?
There's 1 overloaded. I think there's 1 overloaded method in child.
Oh, this is overloading, not overriding.
Oh. Okay, my bad.
So let's talk about the child's interface again. Right? So you start at the most base class. In this case, grandparent is most base. So we get foo with I'm just gonna do it numerically. We've got the foo taking 1 and we've got the foo taking 2 being defined here. Next, parent steps in. Yep.
Foo actually takes 3 in the child. There's 3 in the child.
Foo takes 3 in the child, yes.
But grandparent only has 1 and 2. So wouldn't that be an overload and not an override?
This is an overload, yes. But we have overloads and overrides going on at the same time. The next one that you integrate is parent. Right? This is the definition for grandparent. We layer the definitions in parent over top of grandparent, and we're not done yet. Right? So, parent contains foo taking 2. Right? So, foo taking 2 here gets replaced with foo taking two defined here. Now we need to layer in the final class, which is child, right? So in child's definition, I'll do child in blue. We have a foo taking one, so that overrides the definition in grandparent. Foo taking one. Then we layer in the definition of foo taking three. Foo taking three. That definition is provided here. We have run out of classes and interfaces to smush together, so this is the final one. We have 3 overloads of the foo method. 3 overloaded versions of foo. Foo1, Foo2, and Foo3. All of these are available to an instantiated child class, assuming all these methods are public, which they are. If they're private, that's a whole different story, but this is for public. So you'll notice that none of the method definitions inside of grandparent actually make their way through to the final interface. Both these definitions are overridden. Does that make sense?
Yep.
Good. Does anybody have any questions about this? Because this is like, there's definitely a test question like this.
Can you repeat again, like,
So, what part do you want me to repeat?
like, is it all overloading or is it all overriding?
It's doing both,
So,
right? So, grandparent has 2 overloaded definitions of foo. This definition of foo is overridden by child, which overloads foo to have 1 and 3. The definition of, this definition of 2 is overridden by this definition in parent, but all 3 of these end up in the final interface as overloads of each other. So we have both overriding and overloading happening at the same time. Does that make sense? So, just to recap our definitions, overriding is when a method in a subclass provides a definition for the same method with the same interface as in a superclass. This one is taken instead of that. It's a replacement. Overloading is not a replacement. It's adding another option. So when we hit child and we integrate foo taking 3 ints into our interface, that overloads foo. Does that make sense? Yes.
so the only method that's overloaded is the one that takes 3 parameters.
So let me
Or just in this example.
Yeah.
Yeah.
let me refine the definition somewhat further, all right? So let's distinguish between the method itself and a case of the method, all right? So the method itself is foo,
Okay.
right? A case of the method would be, for example, foo taking 2 ints, right?
Okay.
We have 3 cases for foo in this, in this diagram in general, right? We've got 1, 2, and 3 ints. Each of these are a case of the method, but the method itself is foo.
Okay, so foo taking no parameters is the base of the base method for it.
Well, there's no definition for foo taking, no parameters in this example.
One parameter would be? those-
Yeah, like what I'm trying to do is distinguish between like the method name and the method name with arguments listed, right? So, when you perform overriding, you are always overriding some specific method case. So overriding always applies here. This is override, right? When we say that a method is overloaded, we apply that at the level of the method itself. So foo is overloaded. Now the question is, when we say that foo is overloaded, all that means is that it has more than one case. Right?
Yeah.
But the relationship here, where one definition deletes another definition in the interface, that's what overriding means, and that applies only to one specific case of the method at a time. Does that make sense?
Yeah.
Question.
Are there only two overloads? Are
See-
there two or three?
That's not the correct way to phrase it.
Is it just overloaded? There's not a quantity of overloading?
The correct way to say it is foo is overloaded with three definitions,
Okay.
right? Because the semantic trap that that everybody's trying very hard to fall into is imagining that this is an overloading relationship between two objects, right? Like, you don't say foo taking 1 int and foo taking 2 ints are overloaded together. Because then, if that were the case,
One would be overloaded.
you know, these two are overloaded together, these two are overloaded together, these two are overloaded together. Basically, actually, if you were to define it that way, you would have a number of overloads in a definition equal to like n factorial, where n is the number of overloaded methods, right?
Yeah.
Because it'd be like, you know, if you have 2, you have like going one way, going the other. When you introduce 3, you have now 3. If you introduce another one, you have, or maybe it's not factorial, maybe it's just, you know. And then if you add 5, you have to branch it to everything. So actually, the number of overloads in that situation would be like
The sum?
the sum of n plus n from, yeah, anyway, there's math that's stupid, that's a stupid tangent. So, the way to say it correctly, the method foo is overloaded with n definitions, or like definitions is technically correct, but I'm using the word cases here because it makes it sound a bit more if statement like, right? A little bit more switchy.
Yeah.
And like that is actually the correct way to think about overloaded definitions, because Java is switching between these definitions. It's just based on what the arity is of the function, right? And then I went and used a. You guys know what the word arity means?
No.
No? Yeah, okay. Give me a second. Arity. In logic, mathematics, and computer science, arity is the number of arguments or operands taken by a function, operation, or relation. Arity may also be called rank. Arity is basically if it's all ints, then all we're talking about is arity. But if you're mixing up data types here, then you also, you have a different definition for each data type as well. So it's not quite the same thing as arity, but in this case it is arity because it's all integers. But anyway, any questions? Yes,
So overriding is like when you redefine the method.
precisely.
And overloading is when you add an extra version of the method.
Yes. Yes?
What kind of question can come out of this topic?
You'll have to wait and see. So let's do the code because, this was supposed to be a practical example. So, grandparent, let's start at the base level. In order to have everything redirect to foo, this must call it. So, we are calling foo with one argument. Foo, x plus y. There you go.
Zoom that a bit, please.
There we go. In parent, we don't want to print anything. We want to call one of two things. We have a choice. We can either redirect this operation to this definition or to that definition. I would say that probably technically directing it to this one is more correct as it reduces the number of operations even though the operation is just plus. But if you're trying to minimize code redundancy, then, that's how you would do it. So you would say super dot foo taking x and y. There you go. Because, remember, this definition is overriding that one. Override child contains two definitions. Now remember how overriding works. Which definition is this guy overriding? What class? Grandparent. That's right. This definition in grandparent is passed through to parent, where it is overridden by foo. So even though foo is defined 2 levels up, we still access the version that we're overriding using one instance of super. And for our definition, which takes 3, we want to, well, again, we could do it a couple of different ways. I'm going to do a kooky, crazy way of doing it. Foo. Yes.
The way that it is originally, it has a string of saying like parent foo plus, and then it's not actually adding the integers, it's adding the strings together.
Exactly. The original version is just to demonstrate where things appear. You can leave those statements in and add these method calls to view how the data travels through the methods. I will leave that as an exercise to the reader as we need to move on to our next topic. So, you could just as easily have done this. The end effect of this is that anywhere a comma appears inside of a call to foo, you could replace it with a plus, but a certain number of the pluses actually have to be there. But, okay. So be it. So, polymorphism. Yes.
Just a question about how, so instead of if you wanna adding the parameters as integers, if you wanna like display it as a string, would it be like a different process or?
Yeah, you would leave the code that it had unmodified, but then it completely defeats the purpose. So, polymorphism. From the Greek. Poly meaning, morphic meaning, nope, shaped. Shaped. Morphos means shape. Right? It's interesting. Like in English, we kind of think of the idea of morphing. Morphing is kind of like an English diminution, and it means to change shape in the vernacular, but like if you were to bring it back to Greek, it would probably be like transmorphic or something. I'm not sure if like the trans prefix is Greek derived. Probably not, but anyway. So polymorphism means the property of having more than one shape, right? Both overloading and overriding are forms of polymorphism. We have been studying polymorphism for quite some time now. This time, however, we are talking about type polymorphism. We have talked about method definition polymorphism. Now is the time to talk about type definitions. So, to get through this unit, you must think like the type checker. That's how you must think, all right? It's a good idea to be able to think like the type checker anyway, but hopefully this will generate some insights for you about how the type checking process works. Basically, all of this is done for the satisfaction of the type checker. So, classes create types, right? Subclasses create subtypes. If you want to get right down technical, the type of polymorphism we're talking about is subtype polymorphism, as opposed to like existential type polymorphism, which is what is used in Python. Ask me about that after class. So, a variable of type A can hold references to objects of type A or any subclass of type A. For example, if we have a geometric object, in our example we extended rectangle with a definition of square. One of the other exercises in there is to extend circle with a definition for target. Target is just a circle with another circle drawn in it. That's all the target is. It's like rings or whatever. So, if we declare a geometric object, so a reference variable to an object of type geometric object, it's quite the sentence, we can stuff a circle into it. Alright? So, in the above example, C is of type geometric object, but the object it references is of the subtype circle. So, we're being a little bit clever. What we're doing is we are giving a more specific definition of the thing to the type checker. It's like, this is the conversation. The type checker says, all right, for this variable, I expect a geometric object. And you, the programmer, is like, okay, type checker, here you go, here is my circle. Type checker says, is this a geometric object? And you say, well, it's a kind of geometric object. And the type checker is like, yeah, okay, good enough for me. And then you move on to the next statement. This is the conversation that we have with the computer. So, this makes it a bit tricky though, because now in your brain you must understand that there may be a distinction between the declared type of a variable, or argument to a method, or exception when you're doing exception handling, as we're going to see after the test, and the actual type that that object has. There may be a distinction. They are not necessarily the same thing. So, you can only directly access the fields and methods of the object's declared type. So, basically, in this example here, right, we've got a c.setX. So you'll notice in the geometric object class we have a setX method taking a double. In Circle we also have a getRadius method. Obviously these are incomplete descriptions, not everything is in these, but that's okay. So, c.setX works if we declared C in this manner. System.out.println c.getRadius becomes a syntax error. It is a so does anybody want to guess why calling a method of the object doesn't work? Yes.
Because you declared it as type geometric object, and geometric object does not have the C, the getRadius method?
Yes. So we declared C as a geometric object. So, you guys actually know what a type checker is?
That's in the thing in IntelliJ, making sure that your variables line up to what the method is expecting.
It's actually you're giving the type checker not enough credit actually. It's not just a thing in IntelliJ. Yeah. So, okay.
It's part of the
That's-
runtime
that-
environment.
It's part of Java itself, right? So this is actually, I'm glad you brought that up because this is actually an easy distinction or an easy confusion to make, right? Most of our IDEs do a certain amount of error checking before compilation, right? It's very similar to the spell checker in a Word document or something like that, right? It's running a bunch of checks in the background to see if you're not goofing it up too bad. And of course, it's always annoying when you're in the middle of writing something and it's underlining everything in red just because you're not finished it yet, right? Always annoying. Word at least has the decency to wait until you hit spacebar, right? So, since I know a little bit about compilers, it was the subject of my my doctoral thesis, I can explain to you a few of the top level details. Don't worry, this won't be like master's degree level stuff. Don't worry, guys. So, the compiler, most people kind of think of the compiler as this monolithic piece of software that just does the thing, right? But if you take a look at the structure of a compiler, it breaks itself down into a number of key components, right? Each of them doing a specific task. Now, I'm going to be talking about like compilers in a general sense here. So basically, I'm talking about the C compiler, but Java is similar enough. It has the same components, they just might, a couple of them might be stuffed in the JVM, basically. Although the JVM is mostly doing runtime analysis, but that's okay. So, for a okay, let me use a different marker. A compiler is composed of a number of different steps. If we have our source code file, does anybody want to guess what the first process that it hits is? Not syntax, even before syntax checking.
Type check.
Even before type checking.
Curly brackets checking.
It's actually, the name of it is a little bit funny. You'll be like, yeah, well, obviously. It's called the precompiler.
What?
Yeah. In many programming languages, including Java, I believe, you have the ability to define macros, right? So what a macro, like macro in like a MS Office sense, means you've written some Visual Basic code and you can run that over your, your Excel spreadsheet or what have you, and therefore create massive security vulnerabilities in everything you're doing because I think it's still the case that a large number of ransomware attacks are actually, the vector of that is through VB macros in Office products. But anyway, the precompiler, so what a macro does in a programming language is it's just text substitution, right? So it takes, you can say, for example, define true as 1 and false as 0, right? And that is how C actually does true and false as Booleans. Before it even hits anything resembling the compiler, it goes through the entire document and replaces every true for a 1 and every false for a 0. Integer values, right? So it may shock you to know that C actually didn't have native support for Booleans until 1999, and to this day you have to import a library for it. So it's just, why would you need a data type for that? That's what a C programmer thinks. But anyway, so that's the precompiler. The source code file goes in, gets pre-processed to make all of the exchanges and modifications that are necessary going into the compiler. So the next phase is you must generate the abstract syntax tree. The next phase of the compilation is parsing. So the parser takes the source code and tokenizes it. That is, it breaks it into each of the individual code chunks, like ifs, like the word if in an if statement, that's a token, right? All of the symbols composing the condition inside of an if statement, those are all tokens. Assignment statements are at least 3 tokens, possibly 4 if you're including if statements. The word while is a token. You have to break it into tokens, and then you have to compose a tree structure that is the program, right? So the precompiler and the parser produce what is called the abstract syntax tree. So, I won't go into examples, but if you look up abstract syntax tree, that you'll see lots of examples. The abstract syntax tree then passes into correctness checking, right? So this is the layer at which a syntax error occurs. Syntax errors happen here. If you forget a semicolon, it means that the parser cannot generate the abstract syntax tree. So you get failed out of the process at this level, right? Like, you'll notice when you're working on your programs, right? What do you always have to what does the compiler always throw at you first in terms of errors?
The end bracket or the semicolon.
Precisely. It's always bracket mismatches and semicolons and other just syntactic elements, right? And that's because you have to parse first.
And that's what defines tokens.
Yeah, exactly. Basically, yeah, that's exactly the purpose of the semicolon and the braces, is to define where the tokens are, right? So that's why during tokenization, if your syntax is wrong, you can't generate the abstract syntax tree and you're told to try again with some helpful information, hopefully. Then, after that, we have dun, 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 the type checker. Once this guy is parsed, part of the thing that it parses is type annotations, right? When you declare a variable, you annotate the variable with the type that it's supposed to be. So the type checker traces through the abstract syntax tree, making sure that types aren't being violated. You're not asking for things that a type can't do, right? So once the type checker has run, I'm gonna have a slightly different symbol here. Error produces syntax error. Here, if you've gotten through parsing, error produces type error, right? So, for example, if you are trying to, type error, what's an example of a type error? If you're trying to arithmetically sum booleans, for example, it's possible to do that so that it's correct grammatically, but not correct according to type checking. So, if you manage to get through type checking, you then hit the assembler. And this is like a rough overview. There's like more bits and pieces, but these are the main ones. So the assembler is the thing which takes the abstract syntax tree and produces the executable code, which I will use .exe because Windows, but yes.
The AST, is that what is left over after the parser takes the fancy input statements and turns them into the 17 machine language statements it needs to make that if statement happen?
You're missing the A in abstract. So because it does not include any machine code statements.
So this is like, okay.
So all the
So just like in general. Okay.
yeah, so actually if I wanted to do it correctly, I would do it like this, because like the output of the type checker is not really used to run, right? All it's doing is checking errors and doing that first before you try to assemble it. Yes?
To oversimplify this, is this just a glorified string parser?
I
It just
mean-
takes your text and just breaks it up into all the pieces that it needs to.
If you understand that the thing that's being produced here is not string data but binary data in many cases, right, for a proper compiler, and those that binary code corresponds to CPU, like actual CPU instructions? Yes. All a compiler is it's a big string processing engine. Like a big string processing engine, right? So this is the distinction we're talking about right now. All right? This is the distinction between declared type and actual type. The actual type is what the type of the object is with respect to the assembled program. But the declared type is purely for the purpose of satisfying the type checker. Now, the reason, I will finish my sentence and then we'll get out of here. The reason, the actual honest to goodness reason, why you cannot use the methods of the actual type, you must use the methods of the declared type, is because in Java, the type checker is also responsible for method calls and making sure methods are called correctly. Not only on the right arguments, but on the right objects. Right? So, when it sees c.getRadius, the type checker, which is a very simple beast, all it says is, okay, I'm going to look up your definition for C. I will see that C is a geometric object. Geometric objects lack a definition for getRadius, so you may not call that method here, sir. Boom. So, type error. So the question, and I will just give you one juicy little tidbit before we get away. How do you fix that? That's right, folks. Typecasting. You can satisfy the type checker by manually telling it that this is a circle, despite the fact that it was declared as a geometric object. This provides overriding type information. It overrides what the variable was declared as. Therefore, it's like, oh, let me look up the definition here. This is a geometric object. Oh, wait! I am being asked to treat it as a circle instead of a geometric object. Therefore, it does have a getRadius method, and I can allow this now. So that is how the type checker thinks. Casting is, like, you can understand why Java now has a bit of a reputation for being verbose, in a true sense. And here's the other thing, folks. You have to apply the typecasting to the object before you use the method call, because without that, method access actually binds more tightly than typecasting. So this would be casting the output of getRadius without these braces here. But we can do more examples on Friday. Thank you very much for your time and attention so early in the morning, folks. See you on Friday.